अस्सलाम वालेकुम। सो ये रिजल्ट है आपका विच सेज दैट द लीबैग मेजर इज काउंटेबली एडिटिव। लास्ट वीडियो में मैंने आपको बताया था कि काउंटेबली एडिटिविटी अगर मैं प्रूव कर दूंगी देन आई विल एबल टू प्रूव दैट लीबैग मेजर इज अ मेजर। ओके, सो काउंटेबली एडिटिविटी के लिए क्या है प्रूफ के लिए? सो आई विल टेक अ डिसजॉइंट कलेक्शन of Lebesgue measurable sets 1 to plus infinity. So this countable disjoint collections. So this comes from the collection of all Lebesgue measurable sets, and okay, with these are pairwise disjoint. Ei ej is equal to empty for all I is not equal to j. Okay, and I have to prove that. So what is my claim? I have to prove that the M measure, आपको पता है मैंने लास्ट लेक्चर में आपको बताया था कि it's just the restriction of the Lebesgue outer measure. So measure of this union from I 1 to plus infinity EI is equal to the summation from I is equal to 1 to plus infinity measure of EI. ठीक है, ये आपने प्रूव करना है एंड दिस प्रॉपर्टी इज द काउंटेबल एडिटिविटी। ओके, अब ये ज़हन में रखिए, इट मेक्स सेंस क्योंकि ये ई आईज जो हैं ये तो एम से आ रहे हैं। क्या ये यूनियन भी एम में आएगा? यस, बिकॉज वी ऑलरेडी प्रूव that M forms a sigma algebra, so every sigma algebra is closed with respect to the countable union. So definitely अगर आपके EIs जो हैं M से आ रहे हैं, so this implies your union from I from 1 to plus infinity EIs also belongs to M. Why? Because your M is a sigma algebra. Since your M is a sigma algebra, ठीक है? ओके, अच्छा, अब कुछ ऐसा है कि वन वे इज ऑब्वियस। वन वे क्यों ऑब्वियस है? क्योंकि Lebesgue measure is just the restriction of the Lebesgue outer measure, and Lebesgue outer measure satisfied the countably subadditivity. So countably, so obviously the Lebesgue measure is also satisfied the countably subadditivity. So as Lebesgue measure satisfied countably subadditivity, so this implies your M of union from 1 to plus infinity EI is less than and equal to summation I from 1 to plus infinity M of EI. So this property is the countably subadditivity, and we already proved that the outer measure satisfies the countably subadditivity. So the Lebesgue. So we denote this equation or the green color with equation 1. Okay, so for the reverse inclusion, because for the equality, if you have to take this first less than n equal to and then greater than n equal to. So for the reverse inclusion, we will, let's see what you do. So for reverse inclusion, so here I will change the color. So for reverse inclusion, so I will take a finite collection from this collection. So I will take EIs where your I from 1 to n. This collection from this collection जो already मैंने ली हुई है, that is EIs from I is equal to 1 to plus infinity. And I know that the finite union of our Lebesgue measurable set is a measurable sets, and I already prove a result. मैं यहाँ पे result आपको बताती हूँ. I already proved the result. I think we did in our class. That is your proposition 6, and which says that So I already proved that for the finite collection, M of union from 1 to n ei is equal to summation I from 1 to n m of ei. ओके ये हम लोगों ने क्लास में प्रूव किया हुआ है. आई विल राइट हियर बाय प्रोपोजिशन 6. लेकिन है by proposition 6 just for the reference I will know this result. Okay, so so this collection we take the finite collection for this countable collection, and for any finite collection I know that the Lebesgue measure of the union of ei is equal to some finite sum of the measure of ei's. So अब क्या करती हूँ मैं? So as your union finite collection, any finite collection ei's is the subset of the countable collection I to 1 to plus infinity ei's. Definitely ये जितनी भी finite collections होगी इसका superset होगा ये. और so this implies because the outer measure satisfied the monotonicity, so the Lebesgue measure satisfied the monotonicity. So M of union from I is equal to 1 to n. ei is the subset of summation I from 1 to plus infinity. Sorry. This is not summation. By the monotonicity, M of union from I is equal to 1 to plus infinity ei's. Okay. And by using this proposition, we can say that by using इसको मैं दे देती हूँ equation 2 का नाम. So by using 2 summation, because this is exactly equal to the sum of 1 to n measure of ei's, and this is less than equal to m of, okay, this happens for all n, ये ज़हन में रखें, for all n लिखना यहाँ बहुत ज़रूरी है. So union from I is equal to 1 to plus infinity ei's, and this happens for all n. Okay, यहाँ पे आप लिखते हैं by 2. Okay, so we have summation I from 1 to n m of ei is less than equal to m of union from 1 to plus infinity ei's for all n. अब ये जो आपकी right left hand side है, this is independent from n because this happens for all n. और यहाँ पे ये है कि because it is independent for n, so when you take for n is approaches to plus infinity, n is approaches to plus infinity का मतलब क्या होगा कि जो आपका ये जो finite sum है from n m of ei's, this will be approaches to the infinite sum, so that is from I is equal to 1 to plus infinity. क्योंकि ये अगर आपको याद हो तो m of ei's के m of ei's are the positive number, और ये जो आपका होगा इट्स जस्ट द पार्शियल सम. ठीक है, यानी अगर आप सीक्वेंस ले रहे हैं नंबर्स का m of ei's का, ठीक है, और यहाँ पे ये जो आपका i है वो 1 से प्लस इंफिनिटी की तरफ जा रहा है, तो आपका जो पार्शियल सम होगा Sn वो क्या होगा आपका फर्स्ट I इज इक्वल टू 1 टू प्लस इंफिनिटी m of ei's. ठीक है, अब ये अगर आपका पार्शियल सम है और आपको पता है कि आपकी जो जितने भी सिंस ऑल योर m of ei's are positive क्योंकि ये एक नॉन नेगेटिव फंक्शंस है for all I. So this implies this sequence Sn is an increasing sequence. और आपको पता है कि monotonically increasing sequence जो होता है that always converges to its supremum. So ये अगर आप देखें तो ये जो partial sum की लिमिट होगी ये क्या होगी आपकी infinite series होगी, और यही आपके सुप्रीमम होगा इसका. ठीक है, अब यहाँ से इस इक्वेशन से आप यहाँ से अगर आप देखें तो ये मैं यहाँ पे लिख रही हूँ. ठीक है, फॉर ऑल एन. सो यहाँ से आपका ये है कि लिमिट एन एस एन आपका क्या, एस एन आपका ये फाइनाइट सम. ठीक है, ये मैंने सॉरी ये फाइनाइट सम है, ये इनफिनिट सम नहीं है. सो ये आपका फाइनाइट सम है. सो दिस इज योर फाइनाइट सम. सो एस एन ये बेसिकली आपका क्या होगा, ये आपका समेशन फ्रॉम 1 to प्लस इंफिनिटी होगा, एंड दिस इज एग्जैक्टली योर सुप्रीमम एस वन. सो दिस इज एग्जैक्टली योर द सूप ऑफ एन एसेंस. और ये जो है ये आपका क्या है, ये आपका अपर बाउंड है, इस पूरे सीक्वेंस का ये अपर बाउंड है. तो डेफिनेटली जो सूप होगा वो उससे लेस होगा. सो फॉर n इज अप्रोचेस टू इंफिनिटी ओवर दिस इक्वालिटी, मैं नेक्स्ट पेज पे लिख रही हूँ. सो you have summation I from 1 to plus infinity, because you are applying n is approaches to plus infinity. So m of ei's is less than equal to m of union from 1 to plus infinity ei's. ओके, सो ये आपकी इक्वेशन 3 ले लें. सो अगर आप इक्वेशन सो कंपेयरिंग सो फ्रॉम 1 and 3 we get m of union ei is equal to the summation of m of ei's countable union. So this implies m is countably additive. So if it is a countably additive, so this implies m is a measure and then known as the Lebesgue measure. And it's a good extension of length. ठीक है? और so this is your proposition theorem 14, which says that the set function Lebesgue measure defined on the sigma algebra of a Lebesgue measurable sets assigns length to an interval, its translation and its countably additivity. So ये basically आपका, ये अगर आप देखें तो आपका जो theorem number 14 है on your book, so this is the end of this theorem actually. So next videos में हम Lebesgue measure की properties को discuss करेंगे. That is the continuity of measure regards to the ascending and descending sequences. ठीक है? So thank you.